Hi guys, so welcome to another video of software engineering with me. My name is Ritik Rai, and today's topic is IO multiplexing. So let's get started. So, what is IO multiplexing? Okay, so in usually we have heard of concepts like multi-threaded systems, right? So IO multiplexing is a very opposite term for multi-threaded systems, as you can see. Okay, in multi-threaded system, a lot of requests are handled with various threads, right, or like workers. But in IO multiplexing, a single thread does all the work and simultaneously. So what we feel is that the work is still being processed like very asynchronously, but it is not. It is processed very synchronously, as you can say, because there are no multiple threads in this. There is one thread which is handling all the requests. They are not at the same exact time, but the context switches between two requests is so fast that it feels like that we are currently like working in a very asynchronous environment. Okay, so let me explain you this. So here is one request. Okay, this is request number one, and this is request number two, and here request number three. Okay, so what happens is CPU one, CPU sorry, not CPU one, CPU is processing request number one, and so request one says that you need some data for this, right? I don't have this data right now, but let me check the hard disk or like another API and get the data for you, and then we can start the processing, the whole processing on that data once I get all of it. Okay, so what CPU does is it says, okay, yeah, go ahead, show. So it changes its concentration from request number one to request two and says until the request one is coming, let's process our data. So it starts processing request number two's data, and in the meantime, request one has came back with the data. Okay, while it's processing request two, a request to says that I also need some data, right? I need to get some data from some external source, so let me get back to you on this. So CPU says, okay, fine. So CPU, what basically CPU does is on the basis of the implementation of the algorithm of IO multiplexing, it can either go to request number three or it can jump back to request number one. Okay, basically it shifts its focus to another request which currently has all the data and does not need to go anywhere for further gathering of information for processing. Okay, so basically, on the basis of the implementation of the concept of IO multiplexing in various environments and various languages in various softwares, the CPU can change its focus either to request one or to three. Okay, so like one question that may arise is why do we need IO multiplexing, right? So why do we need IO multiplexing? Okay, so one of the things is that in multi-threaded systems we need extra concurrency practices. Okay, extra concurrency practices, and like we need to maintain logs and everything. Okay, and secondly, in IO multiplexing, a lot of resources are saved. Okay. Like we do not need multiple threads in link requests. A single thread is able to handle a lot of requests because in a bit when I'll be explaining how IO multiplexing works, you will understand why this extra resources are wasted in multi-threaded systems in an IO concentrated environment. Okay. So what I eventually mean is that IO multiplexing, as any other concept in computer science, has its pros and cons. Okay, so it flourishes in an environment where the system has to do a lot of IO calls and not a lot of CPU processing. Okay, for example, in Redis, right? One of the major and the best usage of IO multiplexing is in Redis, right? And Node.js. So what they basically do is they don't have to process a lot of data. Okay, they don't have to process exactly a lot of data. They have to kind of like either to store they either have to store the data into the hard disk or like they have to like in Redis's case there is a concept called pub sub, right? So they have to make a call based on the request received. So the processing of the data is not very concentrated on like data manipulation and all. It is very much like IOs. Like there is a lot of input and outputs and not a lot of CPU processor. Okay. So Redis and Node.js thrive in by using IO multiplexing. Okay, so I'll explain you guys now how IO multiplexing exactly works. Okay, yeah. Okay, so let's take an example over here that we have two requests. Okay, and so as you can see from this this marker legend, right? This is the red means IO blockings and the blue means the CPU processing time. Okay, so let's assume that request one and request two come at the same exact time. Okay, so due to some reason, okay, CPU starts processing request two first. Okay, so this blue means CPU is processing request 2. So request 1 is in IO blocking state. Okay. It is blocked right now. It is not being processed. Okay. So yeah, it would look like, yeah, it is like it's really bad. Like why I'm not being processed? Like I could be processed right now if I have multiple threads. No. So okay. So what happens is like in request 2, after it being processed, request 2 says like I have to go make an IO call. So CPU says okay, go. So now it has time. So it switches to request number 1. Okay, it starts processing the request. And request number 1 also says, yeah, I have to make some IO calls. Let me get back to you on this. So now the CPU has some idle time. It even has some idle time right now. Okay. So resources are being saved. And then request 1 comes back and says, yeah, let's get back to where we were. I have the data for further processing. And so it starts processing the data. Meanwhile, request 2 actually came back a little before the request 1 was fully processed. So request 2 is in a waiting state. Okay. So yeah, so once the request one says, okay, now I have to go to like make another IO call. So CPU says, okay, so now I'm gonna process request number 2. So its timeline begins and starts processing it here. Request 2 says, and again, this whole process keeps on going on. So the main crux why the blocking is not a very big deal over here. If request 1 is blocked or request 2 is blocked, it's not a big deal over here because in an actually working system, these calls, these blocks are so small and so frequent that it is almost negligible. The waiting time is almost negligible. Okay, so here we can see a lot of big blocks, but understand this that these there would be a lot of frequencies of reds and lot of frequencies of blues in both of these requests. So it is like for example, in our lives, we try to multitask sometimes. Okay, so for example, we are cooking something in the kitchen. Okay, and we have to bake something. We have to turn on like mix something. We have to like stir a pot, like cook something. Okay, so we can do everything eventually because like if I stir the pot for like 30 seconds, now it does not need constant stirring. I can give it a stop and let it boil for a minute. Until then, I can start the baking. I can put on the timer and start the whole baking process. So I don't have to intervene in this whole baking process right now. So I can go to mixing. I can start the like whole grinder and start mixing various ingredients. I'm doing that. After a while, I can see like the pot is boiling a lot. So I can stop the mixing. I can go to the boiler and start the stirring once again. So this constant context switching is what makes IO multiplexing really efficient and also saves a lot of resources. Because, for example, if there were three folks in the kitchen, right, and one of them was baking, one of them was stirring, and one of them was like turning on the grinder. So every like there is a lot of wait times, and the baking guy almost has to do nothing almost. Why? Because baking takes a lot of time and is basically a very automated process. They don't have to take a lot of manpower at that time to do that. So that one person is like a waste of resource at that point of time, right? Because all he's doing is waiting. So this is how IO multiplexing thrives in a lot of environments, which are basically very IO intensive and not very CPU and data processing. Okay. So I hope you guys like this video. So please subscribe to my channel and see you once again.